So, how much battery should we be putting into our Rocky? It might be handy to do some calculations. And there is a fairly standard formula that's based on the mass of the car, the air resistance at different speeds, the rolling resistance, and it's basically like a formula that we can plug into Excel. This is a theoretical calculation and obviously needs to be validated in the field for each particular car, but it gives us a ballpark figure. So we've got the values for the Rocky here about the resistance coefficient, basically related to the shape of the car, the projected area of the vehicle, the speed we change. You can change. So from that you can calculate the air resistance, and there's a few other factors there. So by plugging these formulas uh, into the Excel, we have a range of speeds here, and we can work out how much energy is required at any particular speed. And if we relate it to different battery capacities, we can sort of get an idea of how far the vehicle will go. One idea we had was to add solar panels to the roof of the car. Obviously, solar panels are a very small component compared to the power required to drive it, but it's worth having a look in terms of what effect it has on the distance you can travel. And so then we use that to produce a graph. So at 100 kilometers an hour, the different, so these are different battery capacities. The blue is 42 kilowatt, 42 kilowatts, up to the green, which is 60. So that's the sort of range that we're looking at. Obviously, could try a whole lot of different battery capacities, but that's about what we thought would fit into the vehicle. If we can fit more, obviously we might try to put more in, but depends on a whole lot of physical constraints in the actual vehicle, given that it's not designed as an EV. So at 100 kilometers an hour, the range is less than, so somewhere between 100 and 160 kilometer range. Not very much, probably less than we'd want. At 80 kilometers an hour, the range gradually increases. At 60, even with a 40 kilowatt battery, can get 200 kilometer range, up to 300 kilometers theoretically. Now, this curved line here is the calculation for with solar panels, and the straight line is without solar panels. So clearly, the slower you go, the more time the solar panels have to contribute to the charging of the battery, and the greater the range. So if you're prepared, or if you're desperate, I mean, the Rocky might be, we might be taking it to remote areas and not have any charging capacity stations anywhere for many miles. So having solar panels, it may be a great advantage to travel at 20 kilometers an hour and get this recharging capability from the panels. So at high speeds, no benefit at all, really. At low speeds, potentially life-saving. So that's a significant issue to consider. It might also be useful to compare the expected range for the Rocky with existing EVs. The yellow line at the top is a Tesla Model Y. The blue line at the bottom of that sort of clustered group is a Mini Cooper SE. And the two bottom lines are the Rocky. The green one is with solar panels and the blue one is without solar panels. So now these are all at these are sort of based on real world data rather than the mathematical model we're looking at before, except for the Rocky. Um, so and they're all at speeds much higher than we'd normally drive because I don't expect we'll be driving over 90 kilometres an hour, which is what all of these graphs are for. Um, so you might wonder, why is the Rocky so much lower than the other EVs? And the answer is that it's not designed as an EV, so it has a boxy shape with poor aerodynamics. It has four-wheel drive tyres as opposed to the low profile tyres that you find on nearly all EVs these days, which have no off-road capability. You can't go on sand or anything with the current EV tyres. So, and we want the Rocky to be able to go off-road. So we've got normal tyres and a boxy shape because that's the shape of the car. But at lower speeds, uh, you can see that it becomes much more competitive with the sort of normal range of EVs. So that's what we're basically aiming for. So this graph here shows the comparative range of a number of electric vehicles and the final converted Rocky theoretically at a range of speeds. Now these speeds are actually much higher than what we'd travel at, because we're unlikely to be travelling at anything over 100 and probably most likely at about 80 kilometres an hour. But you can see the effect that speed has on the range. It's quite a significant impact. And the other thing is the Rocky. So this would be the Rocky, those two bottom lines of the Rocky with about 60 kilowatt hour of battery. One's the green one is with solar panel, and the blue one is without. So at about 80 kilometres an hour, you get over 200 kilometres of range with a 60 kilowatt hour battery. So, so bearing in mind what we were talking about earlier about charging and so on, this is something we have to sort out. Do we want to have more battery to give us a slightly bigger range or not?